Dear students, welcome to Brilliant Kuwait. Then I am going to solve 10 questions from JEE exam 2025. These questions are for you. This first question is, if B is magnetic field and mu 0 is permeability of free space, then the dimension of B by mu 0 is. In this question, we have to find out the dimension of B by mu 0. So, we know that the equation of the solenoid, a magnetic field of a solenoid is equal to B equal to mu 0 Ni is equal to mu 0 Ni by L. This we are doing through a shortcut equation. So here N is the total number of turns, I is the current, L is the total length. So here by rearranging the equation we get B by mu 0 equal to Ni by L. Then applying the dimension of current and length we get current A and length L. So A by L is equal to A L raised to minus 1. So the correct option is option 3 is correct. Next question. Which of the following is the correct dimensional formula for the capacitance in F? M, L, T and C stand for unit of mass, length, time and charge. See, here we have to find out the capacitance. We know the equation of capacitance. C equal to Q by V, where Q is the charge and V is the potential difference. The dimension of charge Q is C. See, in the question it is given that C is given, stand for here charge. They are given charge. So, we know the equation of potential. V is equal to work by charge, that is W by Q. See, if this equation W by Q is substitute in the Q by V, we get C equal to Q square by W. Then we have to apply the dimensions on each term. We are substituting Q is equal to Q square equal to C square, W, we know that ML square T power minus 2. So the answer is C square M raised to minus 1, L raised to minus 2, T square. So option 1 is correct, C square M raised to minus 1, L raised to minus 2, T square. So first option is correct. Next question. This match the following question. Match list 1 with list 2. In list 1, permeability of free space, magnetic field, then magnetic moment, torsional constant. In the right side you can see ml square t power minus 2, m t raised to minus 2, a raised to minus 1, ml t raised to minus 2, a raised to minus 2, L square a. And choose the correct answer from the option it is given. So first, permeability of free space. From the Biot-Savart law, we know the equation dB equal to mu 0 by 4 pi ideal sine theta by r square. Here B the magnetic field, mu 0 permeability of free space, I current, dl length, r is the distance. So from this equation you can see mu 0 is there. So we can find out the dimension of mu 0 by substituting all other terms. So by substituting we get mu 0 is ml t power minus 2, a power minus 2. This matches with third one. Then second one can see the magnetic field. So this we can get the dimension from the Lorentz force equation, that is F equal to BQV sine theta. Here F is the force and Q is the charge, V is the velocity and theta is the angle. See here B is there, that is magnetic field. By substituting the dimension of force, charge, velocity, we can find out the dimension of B as mt raised to minus 2, a raised to minus 1. This is the second option you can see. Then is magnetic moment, M. We know that the magnetic moment is equal to I into A is the equation. So I is the current, A is the area. By substituting the dimension, I is A and A is L square, we get L square A. So it is the fourth in the list 2. Then next is torsional constant. We know the equation of the torsional constant, that is the torque is equal to k theta, where tau is the torque, theta is the angle, k is the torsional constant. So by substituting the dimension of torque, that is ml square t power minus 2, theta we know that theta have no dimension. So we get the dimension of k is ml square t power minus 2. So this is the list 1, this first one. So here option 2 is the correct answer. Next question. In a measurement, it is asked to find modulus of elasticity per unit torque applied on the system. The measured quantity has dimension of m raised to a, l raised to b. If b is equal to minus 3, the value of c is. See, in the question they are telling about modulus of elasticity per unit torque. So you can see the modulus of elasticity by torque is equal to, we know that modulus of elasticity is equal to stress by strain. So stress by strain into torque. We know that the strain have no dimensions. So we are removing strain from the equation. So we get stress by torque. Stress, we know stress is equal to force by area into torque. So by applying the dimension of force, area and torque, we get the dimension of force is mlt power minus 2 divided by a is l square, and the torque, the dimension ml square t power minus 2. So we get, by simplifying here, we get l raised to minus 3. Now comparing with the equation, we get m raised to a, l raised to b, t raised to c is equal to m raised to 0, l raised to minus 3, t raised to 0. So from this we get the value of c is 0. So the answer is 0. C is equal to 0. So these we are doing through the shortcut. Okay, for details we have to work out more. The next question is match the following question. Match list 1 with list 2. In the left hand side you can see angular impulse, latent heat, electrical resistivity, electromotive force. On the right side you can see m raised to 0, l square, t raised to minus 2, ml square, t raised to minus 3, a raised to minus 1, ml square, t raised to minus 1, ml cube, t raised to minus 3, a square. And options are there. See, first you have to find out angular impulse. Angular impulse, we know the equation torque into time. So torque, the equation, the dimension of torque is ml square t power minus 2, time is t. By multiplying and simplifying, we get the answer is ml square t power minus 1. It matches with option 3 here. Then the next we have to find out is latent heat. We know the latent heat is equal to energy by mass. So we know the energy is the same dimensions work, the work dimension is ml square t power minus 2 and the mass is m. So by dividing we get ml square t power minus 2 divided by m, we get l square t raised to minus 2. We can see it is matches with 1, l square t raised to minus 2, that is matches with 1. Then next we have to find out electrical resistivity. The equation of electrical resistivity is RA by L, where R is the resistance, A is the area, L is the length. By substituting R equal to V by equal to VA by IL, then again substituting V equal to W by Q, we get WA by QIL. So then again substituting for QI, we get I into T, we get WA by ITIL. By applying the dimensions of WA, IT, L, we get a dimension of resistivity rho is equal to ml cube t raised to minus 3, a raised to minus 2, which is C matches with option 4, m l raised to 3, t raised to minus 3, a raised to minus 2, option 4. Then the last one is EMF, electromotive force. We know the equation of EMF is equal to work by charge. Work, we know the dimension of work is ml square t power minus 2 and charge is A into T. So by dividing we get ml square t power minus 2 A T, we get ml square t power minus 3 a raised to minus 1. So it matches the ml square t power minus a raised to matches with the second option, that is ml square t power minus 3 a power minus 1. So the correct option is 4. Now next question. The expression given below shows the variation of velocity v with the time t. V is equal to a t square plus bt divided by c plus t. The dimension of ABC is, so here we have to find out the dimension of ABC. For the method is first the dimension of A, then B and then C, then multiply A, B, C. So we get the dimension of A, B, C. So in the question, you can see in the question, V equal to A t square plus BT by C plus T. So here this is the question. Then here to solve this, we have to apply the principle of homogeneity. We know by principle of homogeneity, we know that dimension on either side of the equation type or each term is same, dimension of each term same. So dimension of V equal to dimension of A t square is equal to dimension of BT by C plus T. So the dimension of A is, so you can see V divided by T square, dimension of V divided by T square. So LT raised to 1 T square, you get LT raised to minus 3. Then the dimension of C, you can see here bt by C plus t. C is adding with t. That means both should have same dimension. Then only we can add. So C have the dimension of t. Then we have to find the dimension of B. You can see bt by C plus t. We know C plus t have the dimension of t, and here t have the dimension of t. So by cancelling, the dimension of B is equal to dimension of V, so is equal to LT raised to minus 1. So we got dimension of A, B and C, they multiplying LT raised to minus 3, B LT raised to minus 1, and C is T, we get L square T raised to minus 3. So M raised to 0, L square T raised to minus 3. The correct option is 4. The pair of physical quantities not having same dimension is, first one, pressure and Young's modulus. Second one, surface tension and impulse. Third one, torque and energy. Fourth one, angular momentum and Planck constant. See, here first they are giving pressure and the pressure. See, pressure versus Young's modulus. Pressure, you know, pressure is equal to force by area. So by we substituting the dimension force and area, so we get force ml square, ml t power minus 2 and L square, we get ml raised to minus 1, t raised to minus 2. Then Young's modulus, we know Young's modulus is equal to stress by strain. Stress by strain is Young's modulus. Here we are removing strain because strain have no dimension. So Young's modulus dimension is equal to the dimension of stress. Stress is nothing but the pressure. So force by area. So we get ml raised to minus 1, t raised to minus 2. So both, you can see both have same dimension. Ml raised to minus 1, t raised to minus 2. Then next we have to find out surface tension versus impulse. Surface tension is equal to, the equation is force per unit length. So we are, by substituting the dimension of force and length, ml t power minus 2 and length L, we get m L raised to 0, t raised to minus 2. Then impulse, you know the equation of impulse equal to change in momentum. Momentum, the equation mass into velocity. For substituting mass and velocity, L t raised to minus 1 m, we get ml t raised to minus 1. So you can see both have different dimensions. Then the third one is torque versus energy. We know that torque is equal to force into perpendicular distance. Force into perpendicular distance is equal to, by substituting was ml t power minus 2 and L, we get ml square t power minus 2. Then energy, we know the dimension of energy is nothing but work, and which is equal to force into distance, which is equal to ml square t power minus. So you can see ml square t power minus 2, ml square t power minus 2, same dimensions. Next, we have to find out angular momentum and Planck constant. The angular momentum, the equation is mvr, mass into velocity into distance, and mass is m, velocity L t raised to minus 1, r is then again L. So we get m L square t raised to minus 1. Then we have to find out the dimension of Planck constant. We know the equation of Planck constant, E equal to h nu, E energy, h Planck constant, U equal to frequency. So by we get the dimension of h from E by mu, by substituting the dimension of E and U, you get the dimension of h is m L square t power minus 1. So you can see both angular momentum and Planck constant have ml square t power minus same dimension. So the correct answer is surface tension and impulse. Option 2 is correct. Next question is a match following question. List 1 is Young's modulus, torque, coefficient of viscosity, gravitational constant. On the right side you can see ml square t power minus 2, m raised to minus L cube, t raised to minus 2. Okay, then choose the correct answer from the option given below. See, Young's modulus. We know the Young's modulus is equal to stress by strain. Here we are removing strain because we know that strain have no dimension. So the dimension of Young's modulus is equal to dimension of stress, which is equal to force by area. By substituting dimensions, we get the stress is equal to, here you can see m L raised to minus t raised to minus 2. It matches with second 2. Then next is torque. You know the torque. The equation of torque is force into perpendicular distance. So force ml t power minus 2 distance L, we get multiply, we get ml square t power minus 2. It matches with 4 here. So then coefficient of viscosity. So the equation of coefficient of viscosity, F is equal to eta AV by L. By rearranging, we get eta is equal to FL by AV. Where eta is the coefficient of viscosity, F force, L length, A area, V is the velocity here. So by substituting all these dimensions F, L, A, V, we get the dimension of eta is m L raised to minus 1, t raised to minus 1. So it matches with the first option. Okay, then next one is the gravitational constant. So by Newton's law of gravitation, we know that F equal to gmm by r square. And by rearranging the equation, you get G equal to Fr square by m square. F is the force, R is the distance between the masses, m is the mass. By substituting the dimension of F, R square, m square, we get the dimension of G as m raised to minus 1, L cube, T raised to minus 2. It matches with the third option. Okay, then you can see the correct option is 3. Match list 1 with list 2. In the left side you can see magnetic induction, magnetic intensity, magnetic flux, magnetic moment. On the right side you can see ampere meter square, Weber, Gauss, ampere per meter. Choose the correct answer from the option given below. You can see here left side the quantities are given and right side the units are given. So you have to find out the units. So first magnetic induction, the magnetic induction nothing but the magnetic field the units are Tesla and Gauss we are normally using. So here they are given Gauss. So the answer is the C matches with C. So then next one is magnetic intensity. Magnetic intensity, the magnetizing field H, we know the unit is ampere per meter. We can find out the unit by H equal to B by mu. By using that equation also you get the dimension, magnetic intensity. Then the third one is the magnetic flux. Magnetic flux nothing but the unit is Weber. Then magnetic moment, we know it is the strength of magnetic moment is the strength of the magnetic field. So and the equation is magnetic moment m is equal to current into area, that is I into A. By substituting the dimension of current and area, the current is A and area is m square, the unit is ampere meter square. So you can see the correct option is 4.